Hi everyone, so today we are solving the question first missing positive, which is labeled as the hard question of the lead code. So let's start reading through the question. So the question says that we are given with the unsorted integer array nums and we have to return the smallest positive integer that is not present in nums. So we have to implement an algorithm which is running in the time big of n and uses big of 1 of auxiliary space. So the question is really very interesting because of this particular statement they have provided. Without this statement, this question is very easy, but with this statement, this question is a little bit difficult. So let's understand the question first. So what the question wants us to do. So first the question, we can just take one example. Let's say we are having nums as 1 comma 2 comma 0. Now first of all I would just have to clear you all that here we have to find the smallest positive integer from the array. So the positive integer from this array will not include 0. So it would start from 1 to n. So this is a very important point for solving this question with any method. Secondly, if we just find the output for the example we have took, so just see it's having 1 2 and 0, and we can see from the question that we have 1, we have 2, but 3 is missing. That means our output should be 3. Right, now we can take the second example. Second example says that we have 3 4 minus 1 and 1. So from the particular example we can see that minus 1 is not included because it's a negative number. So which numbers we have to include is 1 3 and 4. Now we will be starting with 1 and see that which number is there. So we will be going with 1, then we will have 2. So 2 is not there, so that means our output should be 2. Next is a very good test case, and I think that defines the beauty of this question. First is 7 8 9 10 11. Now your output should be 1 for this because it is the smallest integer, positive integer, which is not present in nums. Now I would be thinking that why 1? Why not 12, or why not any other number? Because there is nowhere said that we have to find the consecutive numbers. We have to find the smallest positive integer which is missing in this particular array. So that means that is a 1 which is not there. So I think so that it's pretty well clear from this particular example that you are not having in this question 1 is the number which is not present in the integer in this particular array. Okay, so let's redefine this particular test case so to dive better. Okay, so let's say if I just delete 8, so you might be thinking that the particular answer for this question should be 8. Why? Because that is a missing number, right? 7 8 9. So as cleared by me, that second thing you have to be understanding in this question is that numbers are not said to be consecutive. The number is not said to be consecutive, and for that reason we will just include the smallest integer which is not present. So I think this is pretty well clear, and the question is pretty well clear with these 3 examples and the 2 conditions which we have look. Okay, so let's start with the approaches. For this particular question we can have many approach, but I have 3 approaches. See, first approach is with the help of hash maps. Second approach is with the help of sorting. Third approach is with the help of the rearranging of the nums array. Accordingly. Fine. Okay, so let's go with the first approach, that is of hash maps. So hash maps approach is really very easy, and I will discuss what's the problem with that approach. So we have hash map. We can take the hash map as another map int comma int. Now the thing is that we have to push all the integers and the frequency in the maps. Okay, so what you have to do is you have to push all the integers with the frequency in the maps. So we will have maps nums of I plus plus. Okay, so now we are having a map, and all the numbers with the frequency is pushed to it. Okay, fine. Now what we have to do is we can just give I as 1, and while I is there, we can find that I is there in the maps or not, right? If I is there in the maps, that means that that particular I needs not, it is not missing, it is there in the I. So that means we have to do I plus plus and do the I plus plus until and unless we do not find the I. If we do not find the I, then we have to break the loop. Why? Because we have found the I which is missing, which is smallest I which is missing from this particular array, and at last we will return I. Fine. So this is the first approach which you can use for solving this question. So let's try run this particular approach. First is you are having 1, 2, 0, and I is 1. You will be pushing all the numbers of the array to the map and with their frequency. So 1 will be stored as key and the frequency will be stored as value. After this, you will be assigning I as 1 and you will be running a loop with while loop. Okay, and after this you will be checking that that particular I is there in the loop or not, in the map or not. If it's there in the map, that means it is not a missing number, you will do I plus plus. If it's not there, then break and return I. So it's pretty simple to understand, I think so. The question says that, okay, so the question, the error says that I have not put the comments here. 1 second. Fine. Now I will run this again. So all the test cases are running and we will submit the solution. Okay. Now I was telling you that what is the problem in this particular approach. This approach is pretty good because it's taking the time big often, but it is taking the extra space, that is big often again, and we have to do this question big off one time. So this particular problem is not following the description. This particular solution is not following the description given by the question, and we have space complexity as big of n again. So this particular problem, this particular solution is correct, it is accepted, but still we are lacking this particular description. We have not implemented an algorithm which will take big of one time. Okay, so let's try our luck with sorting algorithm and just see that if that works. So let me comment this out. Now we will use a sorting one. So in this particular algorithm, what you have to do is you have to sort the array. Simple. Sort the array from begin to end. So we will sort the array from begin to end. You will get the array as 0, 1, 2. From here you will get -1, 1, 3, 4, and here you will get 7, 8, 9, 11, 12. So now you can see that this is now pretty much clear to you that what we have to do is we will just have the same approach. We will define j as 1 and we will be running a loop from the nums array and doing this approach again. So we will run the loop nums.size I++. After this, what we have to do is we have to check that if nums of j is present, nums of I is equal to I or not, is equal to j or not. So if it's equal to j, what we have to do is we have to do j++, and if it's not equal to j, then we have to do I++, and we have to do I++ until we reach the end of the loop. And if we reach the end of the loop, we will be having that j which is not present in the loop, and then we will be returning j as answer. So let's run the loop. So it would be working fine. Let me tell you that what is happening here again if you didn't understand. So first of all, what we have done is we have sort the array, and if we sort the array we will get the answer as 0, 1, 2. After that we have defined the j in the same manner we have defined earlier. So I told you that we can have the positive number as 1, so that's why I have taken the value from 1. I'm not taking it from 0. So if anyone has confusion about that, so I'm clearing it again. After that, what we have to do is we have to check that nums of I is equal j or not. And as the array is sorted, so in that case you don't have to worry of the case when the number is bigger than the I and you're missing some numbers behind. So it is sorted, so you will have it as 0, 1, 2. Okay. And after this, what you have to do is you are having j as 1. Okay, so you have to traverse the whole array and you have to check that j is that nums of I is equal j or not. So when you will be on the 0th position, 0th index of this nums array, then my j's value is 1 and my nums of I value is 0. So 1 is not equal to 0, so what we have to do, we have to do I++ and we will go to the first index of the array. Now j value is 1 and the nums of I value is also 1. So we have to do again j++, so j will be increased to 2. After this we have to check, we will do I++, so we will be on the second index of the array and we will check that if nums of I is equal j or not. So it's equal, 2 and 2 are equal, so that means that we have to do j++ again, and now we have traversed all the array and my answer is 3 because 3 is not in the array, so we will return j as my answer. So you can try run this code for this particular example 2 and example 3 as well. It will work fine for them. So I will submit the question. So this particular solution is also a very good solution, and it has used the algorithm approach from the first one only, so it's a good one. So I will just tell you that what is the problem on this. Now space complexity is bigger of 1, but time complexity is bigger of n log n. And now this is a problem because we have to solve this particular question in bigger of n time complexity and bigger of 1 space complexity. Now we are having time complexity as bigger of n log n. Why? Because we have sorted the array. Sorting takes a time complexity of bigger of n log n, and that is the reason this particular solutions also fail for the particular description given this particular question. So now what we should do, that we can do this question in big of n time, and time complexity is also big of n and space complexity is big of 1. What we should do for this? So if you have to do this question in big of n time in big of 1, so just think something, like think from the above approaches, you will find the solution. How you can do this is, you are given with 1 comma 2 comma 0. If you swap 0 with 1, okay, and you will get 0, 2 and 1. And if you swap 1 with 2, then you will get 0, 1 and 2. Now your array is sorted, and now you will traverse through the whole particular array and find that particular I is there in the array or not. Pretty much clear with this particular approach. Let's try for this one. You have to again do the same thing, okay, but you have to check for some conditions. What those conditions would be, I will be telling you. Here, first of all, you have to check that what is the size of the array. Size of the array is n. Fine. Now what you have to do is, you have to traverse the whole array. Okay. So we will traverse the whole array. After this, we have to swap the numbers until and unless our array is sorted. Now we have to sort the array only and only when our some conditions are satisfied. So we will use a while loop. What you have to do is, if nums of I is greater than 0. So first of all, you have to check this condition, that your particular number, your particular integer should be greater than 0. It should be positive, because we have to find the positive integer, so we will not deal with the negative integers. So it should be positive. Second, nums of I should be less than equal to n. Why I am talking about less than equal to n? Because you have to sort the array and you have to give the answer as swapping the two numbers in this particular sequence. So if we have this, nums of I is greater than 0 and nums of I is less than equal to n. So my I have to check that nums of I is less than equal to n or not. Fine. So these are the two conditions which you have to follow. Okay. Another condition you have to follow is that your nums of I minus 1 is not equal to nums of I. Then only you have to do this condition. And swap is nums of I minus 1 comma nums of I. Fine. After this, what we have to do is, we have to run the for loop again. And if we will run the for loop again, then we have to check that nums of I should not be equal to I plus 1. If nums of I is not equal to I plus 1, then we have to return that particular I plus 1 as answer. And if all the numbers are present in the nums of I, then we have to return n plus 1 only. Okay. So now I will tell you again that what we are doing here. See, just take this example. Okay. Let's take this example. We have 1, we have 2, we have 0. Now what you have to do is, you have to find n. So n is 3 and you have to traverse the whole loop, whole array, and you have to check. Okay, so first of all, you are having while you have to run the while loop and place all the numbers on their places, on their fixed places. Okay, so in this particular example, if you are having 1, 2, 0, so they should be placed in the manner 0, 1, 2, because 0 should be for index 0, 1 should be for index 1, and 2 should be for index 2. Okay, so let's do it. First of all, we have to check that the particular number is greater than 0. Okay, so 1 is greater than 0 and I have to check that it is less than equal to n or not. So it is less than equal to n. And last condition was that nums of I minus 1 should be not equal to nums of I. So nums of I minus 1. Nums of I is 1 and 1 minus 1 is 0 should not be equal to nums of I. Okay. After this condition, you will be running the while loop and you will swapping all the numbers accordingly. After swapping all the numbers after running the while loop, you will get your answer as 0, 1, 2. Okay. Now you have to run the for loop again. Fine. And then you have to check that nums of I, if it's not equal to I plus 1, then you have to return I plus 1. See, so we can see here that nums of I, that is 0, is equal to I plus 1, that is 1. Again, nums of I, that is 1, is equal to I plus 1, that is 2. And again, nums of I, that is 2, is not equal to I plus 1, but yeah, we are on the case, and here my answer would be I plus 1. Why? Because 2 is not equal to I plus 1. So in this case, my answer should be 3. Right? And after, if we just check all this condition, we not get the answer, then my answer would be n plus 1, 4. Why? Because if all the numbers are present, like 0, 1, 2, 3, all the numbers are present, or 1, 2, 3, all the numbers are present, that means the next number would be there. Right? So here 0, 1, 2 was there. That's why on the second index you will get the answer as 3. But if your test case was 1, 2, 3, so now you are having 1 as answer, 2 as answer, and 3 as answer. So in this case you will traverse a whole loop, but you will not get the answer. So you have to return 4, because 4 is the first positive number which is not in this particular array. So this is the approach, and I think it's pretty clear. This particular step was very efficient for this particular approach, and this approach is now taking big of n time and big of 1 time space complexity. So I think this particular approach is clear to you all. We will submit the problem. Okay, so we have done this problem with 3 solutions, and we have also seen that how their time complexities and space complexities are varying, and how can we improve it with different approaches. So all the 3 particular solutions are correct. The only difference is that space complexity and time complexities are varying. So thank you so much.